when we consider this Hadoop, it is having
Ravi,
yeah, hi, Divya.
are you sharing anything with us?
Yeah, I'm sharing. Are you not able to view the screen here?
No,
Can you see the screen now?
no.
What's going
Yeah, now I can see it.
on? Okay. So we are going to see this map reduce with Hdfs. A Hadoop distributed file system is having two major components. One is the Hdfs that we have seen so far, and the second component what you are having here is nothing but the map reduce. So at this point of time, you guys know what is the purpose of this Hdfs. It is basically used to store the data. So it is not only used to store the data for smaller data sets. The minimum expected data set should be in terms of gigabytes and terabytes. So it is the entire file is not going to be stored in a single node. It is expected to be stored in multiple nodes. It is also going to have the replication factor, and it is based on the concept of a client server architecture in terms of the name node along with the data nodes. These are all the things that we have seen. Okay, so if you have, assuming that if I have a file, see here, I have a file which is nothing but your file.txt, okay, which is of 1 terabyte in size, 1 terabyte in size. Okay, now you know, like a single file cannot be stored. A single file cannot be stored in the HDFS in a single location, but instead what it will be done is it will be divided into multiple splits. Okay, those multiple splits are treated as the blocks. Those multiple splits are treated as the blocks. So assuming that your this file.txt has been split into three blocks. Three blocks, just for the example sake I'm saying, and these particular three blocks are treated as a.txt, 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 and this is also treated as b.txt, and this is c.txt. This is what is your c.txt. These are treated as the file splits. Are also what we do is that we also treat them as the blocks. Okay, and each block in the case of HDFS is either is having a default size of 64 MB or 128 MB size here. Okay, now when a client, assuming that you have a client who would like to store this particular file, whom he will be contacting, Cameron? Whom will be contacting?
Node.
What node? He'll be contacting a node,
Name
and
node.
that particular name node is called as a name node here. Okay.
Yeah.
You'll be contacting this particular name node. Okay. So this name node is treated as the master, and then you're going to have the slaves here. You're going to have the slaves here. That is 1, 2, 3. 3, and then you're also having something called as there are 4 data nodes here. Okay. This is treated as data node 1. This is treated as data node 2. And then this is data node 3, and this is data node 4. Data node 4. Okay, so initially what it does is whatever the data nodes that is nearer to this particular name node, all those particular blocks will be assigned like this. So here, what I'm going to do is I'm going to assign a file. I'm going to assign 1 minute. I'm going to assign this block which is of a.txt here. Here I'm going to assign this a.txt. A.txt is being assigned here, and here, and I need to maintain 3 replications, right? So here I'm going to assign this b.txt also as well. This is a.txt is being assigned here, and in data node 4 also what is being done is I have this a.txt that is being assigned here. data.txt that is being assigned here. So simultaneously, what this name node will do here, the name node will try to maintain that metadata here. The name node will try to maintain that metadata in a particular file, and that file is generally treated as a file system, right? FS image. We call them we call this one as an FS image. So here I can specify this one as a.txt is being stored in a.txt. A.txt is stored in the data node 1, like that it will be stored in data node 3 as well as in data node 4. Okay, similarly, I'll specify something like b.txt is stored in 2, 4, and 1, and c.txt is stored in something like 3, it is stored in 2, and it is stored in 1, like that it is mentioned. So here, in one, what you're having here, you're having A, you're having B, as well as you're having C. And in data node 2, you're having only B and C. You're having B as well as you're having C that is existing here. Okay. In data node 3, you're having A and C. You're having A and C. In data node 4, you're having A and B. Like that, the data is expected to be stored here. The data is expected to be stored here, right? So one more thing what you need to understand is that a client will never directly access the name nodes. The client will be able to access these name nodes only with the help of the will be able to access the data nodes only with the help of this name node only here. Okay, we'll be able to access this name nodes with the help of the data here. Now, I told you the Hadoop is nothing but a distributed file system, which is not only used to store the data, but we also need to process that particular data also as well. We also need to process that particular data. So for the purpose of processing the data, Hadoop depends on a strategy, and that particular strategy is generally treated as MapReduce. That strategy is treated as MapReduce, which is nothing but the core part of your MapReduce. So we need to understand what is this map and what is this reduce, and then how it is going to help us in order to solve all these big data problems. Let me tell you, for what purposes you are using these big data use cases. You want to analyze the data as well as you want to do all the different types of operations, be it be healthcare, be it be sensing data, or else be it be commercial insurance, or else be it be any retail stores also, as well as I have told you, like we have the CS use case as well as we have the target use case. And if we want to understand the customer trends or customer patterns, in order to analyze all this massive amount of data, I need to use this processing. So such a type of processing that is used to process the data in the case of this data nodes is generated as MapReduce. It's generated as MapReduce here. Okay, so before you go ahead and then start working with this MapReduce, what you need to understand is we need to understand this is your name node as well as these are your data nodes. These are your name node and then these are your data nodes, right? In the case of the name node, see here. In the case of the name node, in the case of the master node, there are two things here. You're having the name node as well as you're having something called as job tracker. So in the slaves, you're having something like data node, and you also have something like task trackers. Okay, this is your DN, and then you have this TT, task tracker. Okay, and this is your DN, and then you have this task trackers. So that's why one thing you need to understand is data node and task trackers exist in the slave nodes, and name node and job tracker exists in the master node. Okay, and another thing is that all these things what you are having here, suppose when we talk about a name node, the thing is the name node is nothing but it is not a physical node. Okay, it is only a virtual node that will run in its own Java virtual machine, that will run in its own namespace. So that's why in the master, even though the name node and job tracker are present, when they are running, what happens is they'll be running in separate namespaces, or else they'll be running in separate Java virtual machines. So that's why this is if the job tracker is failing, that will not affect the name node, and even if the name node is failing, that will not affect the job tracker. So that's why what we need to understand is the name node or the data node are not the physical nodes, they are nothing but the virtual nodes, they are nothing but the virtual processes. They are nothing but the virtual processes. Can anybody tell me under what port number your name node is running? Under what port number your name node is running? Divya, can you tell me? Under what port number your
5070 50,070.
yeah, how should we give?
HTTP local host and then 12.
HTTP colon localhost colon 50070, right?
Yes.
5070. So that is the place where your name node is running. Okay, so that we have already seen. Now, this is understood, right? You are having a job tracker as well as you are having these task trackers. Task trackers exist in the slave node as well as job trackers exist in the master node here. Okay, now what happens is, assuming that this is a file which is of 1 terabyte in size, and it is distributed across all these data nodes, and this is distributed across all these data nodes. And what I would like to do is that I would like to process this file. I'd like to process this file. Let me tell you how it is going to be processed. So I have a file, okay? So I'm going to take a very small example, and then I'm going to tell you how this is going to be processed. I'm going to have a file. This file is having something like, hi, how are you? Okay, how are your Hadoop classes going on? How are your other ventures going on? And another thing, what you're saying that, how is your family? So this is a small file. Okay, assume that this particular file is of 1 terabyte in size, or 500 gigabytes in size, like this. Okay, 1 terabyte in size here. Just for the simplicity purpose, we'll specify this is 1 terabyte in size. Okay, now the problem assignment is like this. I want to count the total occurrences of okay, every word in file.txt. Okay, every word in file.txt. So Divya, what do you mean by this total count the total occurrences of every word in file.txt? What do you mean by that one?
How many times each of them appeared on that
How many times each word is
inside?
repeated? Suppose if you say how 1, 2, 3, and 4, how is repeated 4 times? Okay, as well as your is repeated 3 times. Like that, I want to summarize all those particular words. And then I need to repeat the total count that word is occurring in this file of text. Okay. Now, so this is what is your problem here. This is 1 terabyte in size. This is your problem statement, and I want to process this one. And this is what is your file here. So first thing, what I need to do, guys, can you please tell me what is the first step I need to do? I also have an 1, 2, 3. Okay, like this. 1 minute. I have 5 data nodes here. Okay, these are 1, 2, 3, and this is 5, and this is data nodes here. These are 5 data nodes. Okay, and then this is what is your problem statement, and I also have a name node like this. This is existing your name node, and I have this FS image that is existing. This is what is your FS image. FS image. Okay. This is what is your FS image, and this is what is your name node. Okay. This is your data node 1. This is your data node 2. This is your 3. This is your 4, and this is your 5. Okay. Now tell me how the process is going to happen first. Sorry, how the storage is going to happen. You please tell me, and based on that one, I'll tell you how the process is going to happen now. Okay.
Blocks first the file is divided in the blocks and then it's stored in 3 replicating.
Yeah. So here you have the client here. Here you have the client who would like to store this program. Okay. So the first thing what is happening is these are the blocks will not be splitted initially, but what will happen is, let me tell you, client is going to approach this name node. Okay. Client is going to approach this name node, and then it says, I have this block of file of 1 terabyte in size, and I want to store this data within this. I want to store this data within this Hdfs cluster. Okay, I want to store this data within your Hdfs cluster. Okay, this is something that this client is going to say in your Hdfs cluster. Okay, now what the name node will do? Divya, Kamran, and who else has joined? What the name node will do?
Name node will check for the space in each of the data nodes.
Yeah, name node will check the space in each of these data nodes. How it is going to check the space? On what basis it is going to check the space?
It is going to have the details you in FS image.
How come it is going to have the details?
Using metadata?
No. What is happening is that every data node is going to send a heartbeat every 3 seconds, and then it is going to send you the block report in every 30 seconds. So based on the information that is being given by the data nodes to the name node, what is going to happen is that all that particular metadata is getting updated in that FS image, right, Divya? That is what is happening.
Yeah.
That is what is happening. So based on the heartbeats, what the name node is getting from the data nodes, it is able to really interpret what exactly is the amount of space that is available. Okay, in how many blocks I can store. All this particular information is going to be calculated by this name node. Okay, so here what we need to understand here is the block size is going to be of 64 MB. In some cases, in other cases, it will be 128 MB. The system what I'm using here is of 128 MB in size, right? It is of 128 MB in size. So here, assuming that this particular file.txt is being split into 2 blocks, for the example's sake. So in this FS image, what I'm going to do is that I'm going to maintain that metadata as F1. F1 is the first split. Okay, it is being stored in 1, 4, and 5. 1, 4, and 5. It is being stored here. Okay, and you're going to have the second split of F2. F2, okay, which is going to be stored in 2, 3, and 5. This is going to be stored like this. Okay, so here in one, what I'm going to store? I'm going to store this F1. F1, and what is the next one?
F1 and 4.
And then
4 node 4.
F1 is going to be stored.
And fifth node. And fifth as well.
Stored, and then in 5 also F1 is going to be stored. Okay. Guys, you need to understand this concept very carefully. Why? Because this is something that is going to decide your entire architecture of your MapReduce. Okay. So 4.1 is stored here. Now, when you take this F2 stored here, F2 is stored in 2. This is your F2. Okay, and F2 is also stored in 3. This is 3, and then it is stored in 5. So this is F4, sorry, F2. Okay, so let me make a split in between.
Is that 3F2?
3 is F2, sorry. 3 is F2. 3 is F2. And F is F1, F2. Okay. So, Shravan, you are following. For
Yes, Ravi.
processing 1 terabyte of data, you need 3 terabytes of space. The reason is every terabyte, every split that you are storing is going to have the replication factor of 3. That is the reason we need 3 terabytes of space here. Okay, now this is done. So we have stored this particular data in this Hdfs. This is generally treated as the Hdfs. So Hdfs is a combination of your name node and data node here. Hdfs is nothing but a combination of your name nodes, a collection of data nodes and a single name node. So Divya, I have a question to you. How many name nodes will be there in a single Hadoop cluster? Is it 1, 2, or 5?
One name node.
Can there be any chance where we can have 2 name nodes?
We have different nodes, but I don't think they are replacement for a name node. It's just one name node.
A name node is one and only one. One and only one. Okay. And the data nodes what you are having here can be more than one also as well at the same time. Okay. Now this is what you are having. Now the storage is done. Now what I want to do is that I want to process the data. So name node is mainly concerned only for the storage. Name node is only concerned only for the storage. Okay, so here along with this name node, there is going to be one more program or the service that is going to exist. What is that one that I have told you? That is treated as job tracker. That is generally treated as job tracker here. That is generally treated as job tracker. So like the case that when a particular file has to be stored, the client is approaching this name node. Similarly, when a program has to be processed, what the client will do is that the client will be submitting the program to this job tracker here. The client is going to submit the program to this job tracker. So this is the job tracker. Please follow carefully. This is the job tracker that is responsible. This is the job tracker that is responsible for the purpose of executing the program that is submitted by the client. And finally, it is responsible to give the output back to the client. It is responsible. That means that with the help of your job tracker only, the process is expected to start. And that is the main person who is going to be responsible for the purpose of your job completion also as well. So that's why assume that the client has written a program in order to count the number of words within this text file, and that program is nothing but your word count program. So in what language you are going to write? Any idea? Word count program. Yeah, we are expected to write only in this Java language only. Okay, the reason why you are writing this one is all your HDFS MapReduce has been written based on the libraries that has been written in Java. So that's why the core programming that you need to use for the purpose of implementing this MapReduce should only be written in Java. Okay, now one more question. I have told a file is of 1 terabyte in size. Do you think that the program is also of 1 terabyte in size?
No.
cannot be of 1 terabyte in size. So at a max, it can be 25 KB, it might be 30 KB, or else it might be 60 KB for that particular matter, right? So assuming that the word count.java is of the word count of Java, what you're having here is of some 70 KB file, 70 KB file, okay, 70 KB file. So what it is going to do here, step number 1, let me tell you. Step number 1, what is the first step that is going to happen here? Client writes a program. Client writes a program, right? That program is WC, word count .java. He has written a program. What is there in this program is something that we'll be seeing in the later classes. Okay, he has written a program, word count.java. He has written. Okay, now what he will do? You need to execute that job, right? So for the purpose of executing the job, what is the first thing that client is supposed to do? Murali, what is the first thing that client is supposed to do?
Request job tracker.
He need to request that job tracker, right? He need to request that job tracker with some parameters. What are those parameters? So that is correct. So the second step is going to be client will request the job tracker. So client will submit the job to the job tracker. Submit the job to the job tracker. Job tracker. So what is something that he need to tell Divya? What the client need to tell the job tracker?
The size of the program and the file it has to work on.
See, client need to tell the job tracker that, hey job tracker, there is a particular file in that in your Hadoop distributed file system. Okay, so you go ahead and then process that file using this particular program, and then put the output in some directory. These are the things that we need to tell. So what are the things you need to tell? You need to tell the name of the job, the name of the program, okay, and what is the second thing that you need to tell? You need to tell the file name that to be processed, and then you need to specify the output directory where the result has to be stored. To store results. This is clear, Murali. Kamran, is this point clear to you?
Yes, it's clear.
So the client is going to submit the job to the job tracker, saying that with these parameters, he's going to specify that he need to specify the name of the program, the file name to be processed, and the output directory where to store these results. Okay, now what the job tracker will do? Can you guess what the job tracker will be doing?
Job will be the file name to be processed and output.
Will blindly go ahead and then process the file.
Yeah.
How do the job tracker knows the location of the file? It doesn't know the location of the file, right? And one more thing that you need to understand, the program, the request, the client are outside your Hdfs, or outside your Hadoop distributed file system. But what is there in the Hadoop distributed file system? The name node is there, and the data nodes are there, and that your metadata is there. Okay, so here what is happening is that when the client is coming and then talking to this job tracker to process that file, which is nothing but file.txt, what is the first step that it has to do, Divya? The question
See
is that
the file exists.
No. Will the job tracker directly go ahead and then process the file? Can it
No.
do it? So
No.
what she should do?
It should probably go and check with the name node.
Yeah, you should go and then check the name node to specify the location of the file where it is existing in the data nodes, right?
Yeah.
That means that Murali and Kamran, you are following.
Yeah.
So the job tracker should
Job tracker is responsible to find the location through the name node
yeah.
and
And one more thing
FSMH,
is that job tracker
and
by
then it
itself
will be
will
start
be
the
able to
process.
find the location of the file. So that's why what is going to happen is job tracker will contact this name node. See here, job tracker will contact this name node. Okay, and to fetch the metadata where that file.txt is existing. Okay, but here there is one thing. File.txt is split into how many splits? Two splits, right? One is F1 and second thing is F2, right? F1 and F2 it has been split up, but it has been stored in multiple blocks. F1 is stored in 145 and F2 is stored in 235.
235.
Okay. Now the question is when name node is going to return the information to this job tracker, when name node is going to return the information to this job tracker, do you think it is going to return all the blocks of the first split, or else it is going to return only one block? Is it going to return all the blocks of one split, or else it is going to return multiple blocks? Can you tell me?
It should return the one block.
It should return only one block.
Yeah.
See here, F1 is a first split, F2 is the second split, F1 is stored in multiple blocks 145 and F2 is stored in multiple blocks 235 here. Okay, so when name node is being contacted by the job tracker for the purpose of finding the location of that file, okay, so it is not expected to give all the blocks addresses of that first file split and second file split. Instead, it is going to give you only 1 and 2. 1 and 2 in the sense F1 is stored in the first block as well as F2 is stored in the second block. F1 is stored in the first block and F2 is going to stored in the second block. So that's why what is the third step that you can say here?
The output directly to storage.
Yeah, I'll tell you. I have a person here. Shashank, you are following.
Yes, Ravi.
Yeah. So you just try to follow the concept. Okay. For these initial days, where I'm not getting into programming and everything, I'm trying to give you a very plain vanilla explanation what exactly is happening in these lines. Okay. The moment once you do those previous recorded videos, you go by yourself and then I'll take you a one-on-one session and then I'll make you to come up with this. Okay.
Sure. Thank you.
No problem. Yeah. Maybe at your 8 o'clock tomorrow, you can attend one session, a demo session, to really understand what exactly is going with this audio. Okay. I'll invite you for this particular link also. Okay. Yeah. So here, the first thing that we need to understand here is job tracker. Okay. Contacts. Job tracker contacts name node, right? To get the address, get location of the file space. To get the location of file space. Can you guys go on mute, please? To get the location of the file space, which is of F1 and F2. Okay. Now, what the name node is going to return? Name node is going to return. Name node is going to return. One is data node 1 and then data node 2, right? Because data node 1 is the place where F1 is present and data node 2 is the place where your F2 is present. So you might be asking like on what basis the name node is going to return this data node 1 and data node 2. Okay, on what basis is whatever the nodes that are in local proximity of this name node. That means that what are the data nodes that are nearer to this name node that contains these associated splits. Only those particular nodes will be given to you. So maybe in that particular network, generally you are going to have something called as racks. I'll tell you what exactly are the racks at a later point of time. generally whatever the nodes that are nearer to the name node, only that name node data node information is going to be given to the job tracker. So that's why name node is going to return dn1 and dn2. So with the help of this one, job tracker is able to conclude that the first file split of the file.txt is present in data node 1, and the second file split of the file is present in this data node 2. Now your name node process is completed. Okay, now your name node process is completed. So guys, is it clear to you till this particular point, or any questions you are having, please let me know. DJ, is it clear?
Yes, Ravi, it's good. It's clear
Okay.
so far.
One minute, hold on, please. Okay, now the next thing what we need to do is, see here. The next thing what we need to do is the job tracker what you are having has got that information here. Job tracker has got the information. Job tracker has got the information, right, from the name node. So with this one, the role of the name node is completed. Okay, now the place should be between this job tracker and these data nodes, right? The place should be between the job tracker and this data node. So here I'll copy and then I'll go ahead and then place this. No. I need to copy all these things. Okay, this is the place. These are your data nodes. Okay, see, again you need to understand a data node is only the virtual process, not the physical process, right? Not the physical node. So the place where your data node is existing, that is the place where there is one more thing that is existing here, that is called as the TT. It is also called as a task tracker. Task tracker exists. Task tracker exists. Okay, this is what is your task tracker, and here this is what is your task tracker. This is what is your task tracker. Two task trackers are there here. That means that task tracker is nothing but the process that is existing within the slave nodes along with the data node. Okay, so obviously assuming that this is what is your file, this is what is your file, right? So let me copy this file here. This is your file. This is the file that you're having here. So I have told you that this file has been split into two splits, right? So assume that this one is there in the first split. This one is in a split, and the next one what you're having here is there in the second split. This is what is your file 2. Okay, this is file 1. What it is that this is your file 1, F1, and this is what is your F2. Right? This is what is your F2 here. This is what is your F2. You have your file 1 as well as you have this particular file 2 that exists. Okay. Now, job tracker, what it is going to do is that it is going to initiate this. See, just like there is a communication between the name node and the data node, where name node is the master and then data node is the slave. Here also job tracker is the master and then task tracker is the slave. So what this once the job tracker has got the information, what it is going to do is that it is going to initiate this task tracker here, as well as it is also going to initiate this task tracker for the purpose of executing that particular jobs, executing that particular program. What is that program here? That program is there right here. I have written a program already here. I have written a program. What is that program? That is wordcount.java. So what it will do is that it will transmit that wordcount.java to this data node, as well as it will also transfer this wordcount.java to this data node, and then it will start processing that file split in that data node. Okay, so the job tracker is going to initiate a task tracker and delegate the responsibility of processing the data that is there in F1, and here also it is delegating the responsibility of this task tracker for processing the data that is there in this F2. And one more thing, task tracker itself is not going to execute this F1. Okay, similarly the task tracker is not going to execute this F2. Okay, task tracker internally is going to initiate a process. Task tracker internally is going to initiate a process. Okay, and that process is treated as 1 minute. తీసేసే ఇటు సార్ రెండోది ఇటు సార్ మధ్యలో task tracker is what is going to happen is, see here. This is your task tracker. This is your task tracker, and this is your file. So this is your file one here. And here, this task tracker, what it is going to do is this task tracker is going to initiate a process in between. To process the data that is present in the file. Okay, that process is called as mapper. We call this particular process as mapper here. So what happens here? Task tracker is not directly responsible for processing the data. Task tracker is going to initiate a process, and that process is responsible to process the data that is present in this F1 here. Okay, and now understood what is the mapper? What is the role of the mapper here, Divya? You understood what is the role of the mapper here?
Yeah.
Murali and Kamran, even
yeah, the processing.
That is what is treated as a process.
Yeah. But one more question I have, like the task tracker is in the, what is it, inside is a Java program? What is this? Written in?
Task tracker is also Java. Everything is Java only. Everything is Java.
So these are like predefined things. But
Task
like word
tracker,
count we write ourselves.
See, task tracker is a predefined program, predefined process. Job tracker is a predefined process. Name node is a predefined process. Okay, but the mapper and the reducer or the word count, what you are having here is nothing but the user-defined program that the client has written and submitted that program to the job tracker, and the job tracker is transmitting that word count.java to this data node where it is expected to be processed. You understood what I'm saying?
Yeah.
So now just think logically.
If you go in your previous slide, which you written the steps for all, can you jump on the previous slide? Yeah, this one.
Client writes the program word.java. Client means we are the people.
No. Next one. This one. You write like the if contact name node and get the location of the, but I didn't see like any output responses where the job tracker response, like which is providing after processing the count.
No, no, I didn't get you. Can you please repeat the question?
No, like what this exercise, the purpose of this exercise, we need to find the word count in file 1 and file 2, which we already split it and store already in Hdfs. So now the job tracker will be get the response from that. How many words is in this file? How many words in this file?
The moment once your word count program is totally completed, then only you'll be getting, right? Then only you'll be getting the total responses. But we are still at
Okay.
the process of requesting that task tracker to process the data. We are still at the initial stage, Kamran.
Okay.
We are not yet gone through.
Okay. Sorry. Okay.
Got right? So my problem
Yeah,
is
got
this
it.
one. I want to count the total occurrences of each word in this particular text. Okay. So now,
Okay.
and one thing that you need to understand, Divya. For the client, it appears as if it is a single file, right? For the client, that file.txt is a single file. But the splits F1 and F2 are internal to Hdfs. Okay. Now this mapper, what I'm talking about here is expected to process only this one here, and the second mapper what you're having here is supposed to process only this one here. Okay. Now can you tell me what should be processed in the first file, F1 file split? What should be processed in the first file split? And what should be processed in the second file split initially? What should be processed in the first file split?
I think the word count for the first file split.
Yeah, the word count for the first file split. Okay. So what is the word count for the first file split? It is like this. How is something which is from R is something which is from one time. Here is coming like that. You need to get the right? Based on the first page. Simon, can you please mute yourself if you don't mind? Shashank, yeah. Sorry. So here what is happening is this is what is expected to be the first file outcome, first F1 outcome here. This is what is your outcome here. That is how is 2, R is 1, and your is 2. Like that, you are expected to get the outcome here. So this is something that is supposed to be given by the first mapper here. And then you're also going to have this second mapper here. What is the second mapper here? Okay, in this one you're going to have this image. What is that one here? You're going to have high is 1. Sorry, high is 1. How is 2? How is 2? And then Hadoop is how many? 1. And then your is U is 1 and your is 1. Your is 1. Right? This is what is the information. So assume that this is the mapper. Assuming that this is the information, right? So this is the first mapper, and this is the second mapper that is going to give the information here. This second mapper. This is the first mapper. First mapper is going to give this information, as well as second mapper is going to give this information like this. Till here, is it clear? Yes or no? Tell me, guys. Very, very important.
Yes.
Divya, is it clear to you?
Yes, Ravi.
Okay, great. Okay, so high 2, how to Hadoop 1, U1, and this is the thing that I'm getting here. Now tell me, forget about MapReduce and forget about other things. Now what you need to do, in case if you are being asked to complete this objective, count the total number of occurrences of word in each and every file. If you are being asked, what will you do? Can you tell me?
Combine the results.
Combine the results. So in what do you want to combine the results? I need to have the final output. So now tell me, how many times you need to specify here? How is something like this is 2 and this is 2. So how is 4? Okay, as well as your is 3. Your is 2 or 3. Your is 3, as well as R is how many times? R is 1. High is 1. I need to do, as well as 1, 2, 3, 4.
U.
Yeah, U is 1. So assuming that this is the output that you're expected to get here. That means that see here, the output that is being given by the mapper, the first mapper, as well as the output that is given by the second mapper are generally treated as intermediate results only. These are all the intermediate results. Intermediate results here. These are treated as the intermediate results here. Okay. When these are treated as the intermediate results, okay, what is going to happen here? This is intermediate result as well as this is intermediate results. Okay. Now I need to have one more program. I need to have one more program which should be able to combine these intermediate results, further process the data, and then emit the final output. Further process the data and then emit the final output. Okay. So the process that is responsible for the purpose of processing the intermediate outputs that this mapper has given, in order to produce the final output, that particular process is treated as reducer. That particular process is treated as reducer. So this is what is your MapReducer theme. Kamran, is it clear what I'm talking about?
Clear.
Yeah, Murali?
Yeah, it's clear.
Who is this Jahnavi? I don't know. So this is clear, right? This is what is the purpose of the MapReduce. Now, before I conclude today's class, because we are going to study this MapReduce this entire week. Probably Friday night I may not be able to take the session, but we are going to have the sessions Tuesday, Wednesday, and Thursday. Okay. Now my question to you is, how many mappers are required? How many mappers are required?
As many number of blocks as we have to define.
Same as the number of files.
As many number of file splits are there, that many number of mappers are required, right? That many number of mappers are required. And how many reducers are required? In this scenario, how many reducers are required?
One.
But guys, kindly go on mute. I need only one output file, right? I need only one output file that will be able to present all these word occurrences, right? So for that particular purpose, since I'm going to emit the results only in a single file, I need to have only one reducer. Okay, but there might be some cases where I'm expected to where I'm supposed to emit the data in multiple files, multiple final output files. Okay, so for each and every multiple final output files, I need to have the corresponding reducer. Okay, so the number of reducers would be equal to the number of final output files you are going to emit. Okay, and the number of mappers what you are having here is going to be equal to the number of file splits this particular program is going to have. Okay, so is it clear to you? So Any questions at this point of time, or you guys are okay? Tell me now.
So since the file file splitting process is internal, how will we know how many mappers are required? Like programmer is supposed to code that.
Okay, one thing. Where we are submitting the job, we are submitting the job to the job tracker, right?
Okay.
Client is submitting the job to the job tracker. Okay. Now, the job tracker is the person who is responsible in order to decide the number of mappers that are required. Why? Because we are external to Hdfs. We are external to Hdfs. Okay. For us, there is no need for us to understand how many mappers are required. Okay. Client is only the person who is going to decide the file to be processed. Okay. Client is the person who is going to decide the final number of output files. Okay. Client is not the person, or else the user is not the person who is expected to decide the number of mappers that are required. Okay, who is the person who is supposed to decide? The job tracker is the person who is expected to decide the number of mappers that are required based on the number of blocks that the name node is going to return. Is it clear to you?
Yeah.
So here you have the dependencies here. See, client will have the control on the job, will have the control on the program, what he is writing. Client will know this particular name of the file that has to be processed, and client is responsible for understanding the output where that job has to be finally emitted. Output where the job has to be finally emitted. Okay, but the internal to Hdfs, what you're having here is how many task trackers you are going to have, as well as how many mappers are going to be there. This is something that the job tracker is going to decide. So the interplay between the job tracker and the task trackers, what you're having, is going to be purely within Hdfs and nothing to do with the client or the user who has submitted the job for that application. Okay, who has submitted the job for that application. Okay, this is one thing that we need to really understand. Okay, so there are a lot many number of concepts that we need to really see with respect to this word count job and all the other things. In case if this concept is clear to you, maybe what we can do is that we can continue tomorrow. Okay, in order to summarize the high-level steps that are required for the purpose of drafting this MapReduce program, and then if time permits, I'll also show you how to execute this particular job, how to execute this job within Hdfs that I'll be telling you, and maybe on Wednesday onwards, what we'll do is that we'll start writing how to code these particular programs also as well. By that particular time, what I'm going to do is I request Murli, Kamran, and who else? Who are there? Murli, Kamran, Sarvanan have joined today. Who is this? Okay, Murli and Kamran, what I do is that I request you to go through the Java videos that Raidu has given to you, and Shashank, I'll be forwarding the videos to you also as well, Java videos. Okay, I want you to go through those Java basics. Okay, in the 1, 2, 3, 4 sessions. Okay, in order to really understand how exactly you're going to code this particular program. I'm going to tell you these things tomorrow. Okay.
Okay.
Hello.
Hello.
Hi.
Yeah, tell me.
This is my first class for the Hadoop.
Okay. Okay. Jahnavi. Okay.
Yes.
Got you. You are from?
Sorry, which place?
Yeah.
From US.
Okay. Okay.
Illinois.
I'm just asking in which zone you are in basically. Are you in CST
Central.
or EST?
Yes, Central. CST.
Okay, Central. Okay. Okay. So Divya is also from Central Zone. So
Okay.
one thing, Jahnavi, what you can do is that tomorrow Can you make it Jahnavi and who is the other one? Santosh, what is his name? Shashank. Can you guys join at 8 p.m. your time tomorrow?
Yes.
Okay. If you guys can join at 8 p.m., I'll start with the big data basics. I'll start with the big data basics. Okay. And I'll parallelly take you in that particular batch. To make sure that you completely understand those Hadoop, Hdfs, and big data concepts. Okay. Before you also please attend these sessions also as well. Jahnavi, are you able to follow what we are saying today? Jahnavi?
Yes. No, actually.
Okay, no problem. You also sit in this particular class just for your information. But what we'll do is that we'll also take that session and then drive it forward. That session also as well.
So tomorrow
There are a
8
couple
p.m.
of more
CST?
students who are going to join tomorrow's session also as well. And I'll start from the ABC basics and then I'll take you through the entire concepts of Hadoop. Okay?
So 8 p.m. CST?
8 p.m. CST, yes.
Okay, fine.
Ravi, one more question to you. Before start the map reduce programming, should we need to install this Hadoop in our machines?
Yes. I'll be sending you all those details in a day or two. Kindly give me the time till Wednesday.
Oh.
I'll pack up the entire capsule and then forward it to you. Okay? Kindly give me 1 or 2 days. That's it.
Okay. Thanks, Ravi.
No problem. So, Jahnavi, you'll be attending tomorrow 8 p.m. Is it okay with you?
Yeah, okay. I'm good.
Yeah, Shashank, I hope you'll be.
We should online at 10, correct?
Huh? Sorry?
No, our class is also at 10 o'clock, not for 8.
Yeah, 10 EST, yes.
Okay.
Yeah. Shashank and Jahnavi, you'll be joining at your 8 p.m. CST, which is 9 p.m. CST, EST. Okay?
Okay.
Yeah, thanks guys, and we'll meet tomorrow. Have a good night.
Okay, thank you.
Good night, bye.
అమ్మాయిది ఏంట్రా అమ్మాయిది ప్రాబ్లం కంప్యూటర్ వాడింగ్